Hi everybody, my name is Professor Rad, and today we're going to talk about dividing fractions. So Theorem 4 states that in order to divide fractions, we are going to complete the following steps. First, we'll rewrite the division problem as multiplication by the reciprocal of the divisor, and then second, we're going to follow the steps for multiplication. Another way you might have heard of this first step before is keep, change, flip. You keep the first fraction the same, you change the division into multiplication, and then you flip the second fraction into its reciprocal. This is kind of similar to when we were talking about signed numbers and we did keep, change, change. We wrote subtraction as addition of the additive inverse. So what we're going to be doing here is we're going to write division as multiplication by the multiplicative inverse. So you see how those two things are kind of related? Subtracting is adding by its inverse. Dividing is multiplying by the inverse. So that's essentially what we're going to do in order to divide fractions. When we talked about multiplying fractions, we used two techniques. One where we multiplied across and then simplified, and the other where we used prime factorization. In this video, we're going to use the multiply across method once we change our division into multiplication. And in the next video, we will repeat these examples, but we'll use the prime factorization method. So let's get started. Our first example is 3/5 divided by 9/10. So the first thing we want to do in order to divide fractions is rewrite it as multiplication by the multiplicative inverse, or multiplication by the reciprocal. So we're going to keep the first fraction the same, change divide to times, and take the reciprocal, or flip, the second fraction. Once we've done that, we can now multiply. We'll multiply across the top and across the bottom. So 3 times 10 is 30, and 5 times 9 is 45. All right, so next we want to simplify this fraction. Since both the numerator and the denominator, the numerator ends in 0 and the denominator ends in 5, so that means both of these numbers are divisible by 5. So I can divide out a factor of 5 from both the top and the bottom. That's going to give me a 6 up top and a 9 in the bottom. And then both 6 and 9 are divisible by 3, so I can divide out a factor of 3 from the top and bottom, and that's going to give me 2/3. So 3/5 divided by 9/10 is going to give us 2/3. All right, let's take a look at the next example. Here we have 7/12 divided by 28. Now remember, anytime you're working with fractions, it's helpful if both numbers are in fraction format, and you can take any whole number and turn it into a fraction by putting it over 1. That's because anything divided by 1 is itself, so you can rewrite whole numbers to be in fraction form in this way. Now we're going to rewrite this division as a multiplication problem. So we keep the first fraction, 7/12. We change division to multiplication, and we flip the second fraction into its reciprocal. All right, so now we're going to multiply across the top and across the bottom. The top's not too bad to multiply, but the bottom we've got two two-digit numbers. So I'm going to work off on the side here. And just sort of denote some scrap paper, I guess. And I'm going to do 12 times 28. I'm going to use the traditional method for this one. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. I'm going to move over a space to the 2, so I'll put a 0 placeholder. 2 times 2 is 4, and 2 times 1 is 2. Then when I add these up, 9 plus 4 is 13. And 2 plus 1 is 3. So we get 336 when we multiply 12 by 28. Okay, so in context of the problem, this was multiplying these two numbers. So the new denominator is 336, and the new numerator is 7 times 1, which is just 7. Sweet. Now, if this is going to simplify, I like this situation because the numerator is a prime number, which means if this is going to simplify, it will only do so if 7 also goes in the denominator. So let's check. So we'll do 336, and we'll divide that by 7. 7 goes into 33 4 times, because 4 times 7 is 28. And when I subtract, I get 5. Then we'll bring down the 6. 7 goes into 56 8 times, perfectly, because 8 times 7 is 56. So there's no remainder. Okay, this is good because it means that 7 divides both 7 and 336. So to simplify, I can divide the numerator and the denominator by 7. 7 divided by 7 is 1. And 336 divided by 7, we just found, is 48. Okay, now I wanted to do these first two examples completely by hand just to get a sense for, how long this technique takes and what kind of work it's going to look like if I'm working through it by hand. Since we did it entirely by hand, let's check our answers to these two problems using the calculator. So I'm just going to use the TI-36X Pro as my check here, and you can watch some previous videos about how to enter fractions into the calculator so you can check your answers. On this one, I'm going to press my fraction key and do 3 over 5, and I'm going to divide that by the fraction 9/10. And if we did our work correctly, we should get 2/3 on the calculator. Yes, okay. It's always a good feeling when you check it, it comes out right. And then let's check part B as well. We've got 7/12. We're going to divide that by 28. And I'm going to check by the original problem, not putting 28 over 1 or anything, because I want to check what we had originally. And we should get 1 over 48. All right, yes. All right. Okay, so the next two examples where we're going to work on, I'm going to use my calculator to help me with my intermediate steps because the numbers are a little bit bigger than even this like 12 times 28. But just a reminder, this technique of multiplying across and then simplifying can take a while, both to do the multiplication as well as to find common factors that you want to simplify by. Okay. So for the next problem, we have 25 over 16 divided by negative 35 over 36. So I'm going to first rewrite this as multiplication. So we keep the first fraction, change divide into times, and then we multiply by the inverse or the reciprocal. So we flip the second fraction, 36 over negative 35. Now, I like to keep a negative sign wherever it was given to me. So since it was given to me attached to the 35, I'm going to keep it attached to the 35 in the denominator. But as we've discussed before, as long as you have like one negative, it doesn't matter where that negative sign goes. Next, we're going to multiply across the top and across the bottom. So I'm going to do 25 times 36. That gives me 900 in the numerator. And then for the denominator, we're going to have 16 times negative 35. Now before I hit enter, I'm going to quiz myself a little bit. Since I have a positive times a negative, I should get a negative answer, which I do. Cool. So that gives me a negative 560. Okay. So now to simplify this fraction, instead of using the repeated division technique, I'm going to use the greatest common factor technique. So what I need to find is the GCF of 900 and 560. And when I find the GCF, I ignore that minus sign to start out with. In order to do this, I'm going to list out all the common factors, all the factors of 900, and then I'll list out all the factors of 560, and then I'll find the biggest among those two lists. So I'll put 900 here and 560 off to the right. Shuffle my papers a little bit. And remember, in order to find my factors, I'm going to keep dividing until the result I get is smaller than the number I divide by. So 900 divided by 1 is 900. 900 divided by 2 is 450. 900 divided by 3 is 300. 900 divided by 4 is 225. 900 divided by 5 is 180. Let's divide by 6, 150. Wow, lots of factors here. Let's try 7. Oh, 7 doesn't work because we got a decimal, but the decimal is still significantly larger than 7, so we have to keep going. 8, also a decimal. 9 gets us 100. 10 will give us 90. 11 gets us a decimal. 12 will get us 75. 13 breaks. 14 breaks. 15 works. Oof. We're getting smaller, but we're still pretty far away. 16 breaks. 17 breaks. Ooh, 18 worked. 19 broke. 20 worked. Oh, golly geez here. Running into the space that I had for my next problem. Let's try 21. Nope. 22 breaks. 23 breaks. 24 breaks, but we're getting pretty close now. 25 worked. 27 doesn't work either. 28 doesn't work. 29 doesn't work. Ooh, 30 works, and 30 is a double factor, meaning 30 times 30 gets you 900. Whew. So since 30 times 30 is 900, I don't have to go any further because now the numbers are just going to get repeated. So for example, if I did 900 divided by 31, now my answer is smaller, so we can stop. Okay, so I suspect 560 might take a while, so I'm going to pause the video and write out my factors here. Why don't you pause the video and do the same, and then when you're done, you can unpause and see if we match. All right, I'll see you in a moment. All right, let's see how we did. So for my factors of 560, I had 1 in 560, 2 in 280. Then I found 3 had a decimal. 4 worked, 4 in 140, 5 times 112, 7 times 80, and 8 times 70, which is kind of a nice little combo. 10 times 56, 14 times 40, 16 times 35, 20 times 28, And as I was checking my factors, once I divided by 24, my answer was smaller, so then I stopped. Whew, okay, so using the GCF method, now we want to find the GCF, the greatest common factor of these two. So for example, I noticed that 1 is on both lists, 2 is on both lists, 4, as well as 5, 10 is on both lists, 20 shows up on both. Let's see, 28, 35. I think that's it, right? So, yeah, that looks to be 40, 45, 56, 50, 70, and 75, 80, 112, 140. Just checking to make sure I didn't miss any. It looks like I didn't. Okay, so the biggest number that I circled was 20. So that's our greatest common factor. Whew, okay, so we found all the factors of these two numbers so we could find the biggest one. Let's divide both of these by 20. Now what's nice about having my list of factors is that I know that 900 divided by 20 is 45. And negative 560 divided by 20 is going to involve 28. And since you have a negative and a positive, we're going to get a negative 28. So in the end, we get negative 45 over 28. All right, let's check that to make sure we didn't make any mistakes along the way. So we had 25 over 16, and we divided that by a negative 35 over 36. All right, and we got a negative 45 over 28. And a reminder, just because the calculator put the negative out front or up top, it's still okay to keep it in the bottom as well. All right, let's do one more example together. And this time, just for funsies, there's 3 fractions. I can hear your excitement through time and space in the screen. All right, so the good news is if all you have is multiplying and dividing, you can work through the whole thing all at once. So I have multiplication here, and then I have division. So I can keep the multiplication as like my keep, and then I'm going to change the division into multiplication, and then flip just the fraction I'm dividing by. So I can keep this as 2/3 times 10/12. And then this division turns into multiplication, and then this fraction turns into 36 over 25. So anything you're dividing by, that fraction is going to turn into its reciprocal when you multiply. All right, now let's go ahead and multiply across the top and across the bottom. So 2 times 10 times 36 is going to give us 720. And then 3 times 12 times 25 is 900. Okay. Now, how do we want to simplify this fraction now that we've carried out all the operations? So on the one hand, we just did all the factors for 900. So if you wanted to, you can also list out all the factors of 720, and we can find a GCF. You could use prime factorization to help you simplify, or you can divide by repeated numbers. So you can use whatever technique you want to in order to simplify. So for this one, I'm kind of tired of making these lists. That took me a while. So I'm going to do repeated division. And on this one, I'm going to do repeated division, especially because I notice both the top and the bottom end in 0. So I know I can divide out a factor of 10 right away. So 720 divided by 10 is 72. And then 900 divided by 10 is 90. Now, I like this because I know 9 is a factor of both 72 and 90. So 9 times 8 is 72, and 9 times 10 is 90. So we can divide out that common factor of 9 to get 8 over 10. And 8 and 10 are both even, so we can divide the top and bottom by 2, and that will give us 4 over 5, or 4/5. And that's our simplest fraction. All right, so let's check this one, make sure we got the right answer in the end. So I'm going to type in 2/3 times 10/12 divided by 25 over 36. Oh, we got 4/5 in the end. Oh, goodness. Okay, sorry about all that camera shaking. So here you have some Now You Try problems. We've got 4 of them, and you can go ahead and work these out and use your calculator to check and see if you get the right answer. And as I mentioned at the start of the video, in the next video we're going to be doing these same problems, but we'll be using the prime factorization technique instead of the multiply and simplify technique, so you can see which technique you like better. So I hope you have a wonderful day, and I'll see you in the next one.